So random digit dialing, what in this problem tells us if it is homogeneity or independence? It says they take separate random samples. So like I separately make sure I go and sample cell phone only users, and then I go out again and I find landline telephone users. So I'm taking separate samples, which means it is which one? Homogeneity. So our state, what's our first part? Population for this this 4-step is something that I went back and added in that I didn't first teach, but some people got confused with it and this helped. So what were individuals that applied to both groups? Under 30 years old, is that what I said? Yeah. And it didn't say anything US or anything like that at all, right? I mean, it kind of implied it, but so then from there, I go to what? Null hypothesis. So my null hypothesis is that they're what? In the distribution of, so here is my category, which is what? Four, and then now I actually explicitly write out both of them. What were my two different groups? The only difference between this and this is what? There is a difference here as opposed to being no difference. And the only other thing I need in state is what? And was one given in this one? It was given 0.05. All right, plan. What was our method? Some of these fonts don't really look like much like a chi. That's supposed to be chi squared. What's my first condition? So remember, you have to explicitly reference both of them because there's more than one sample here. So you would say I was more explicit in the way I wrote this. The problem didn't say that, but I was just trying to make a point here. So it stated that it was a random sample of both from the cell only and the landline users of users that are 30 years old, which means what? What is my second condition that changes a little bit? And I'm literally checking to see that what? All expected counts are greater than or equal to 5. So I'm actually going to write that every time. And then here I'm basically just going to write in my expected counts matrix. I don't have all of the decimals written out unless they didn't. Did they just go to 2 decimals? The numbers we had, or did they go farther than that? So these should be the numbers. Where did I actually get these numbers if I were doing this in front of me right now? How do I get these numbers? And how can I do it? So column total multiplied by row total divided by overall total. And then what's the other way I can do it? That is the mathematical way to do it. In the process of our class, how do I get them? I'd run a chi-square test, and then where do I actually look? For the matrix that you put expected in, which shouldn't be any reason that you don't put it in matrix B. So here you have to check these separate because we have 2 separate samples. So like there are 96. I'm shorthanding here a little bit. Which means there have to be at least 960 I would expect you to show a little bit more work than that, but as far as just going through the answer key enough right now. And then landline users, there were 104. So you would need at least 1,040 people under the age of 30 that have landlines or are landline users. Questions with anything with conditions? With your actual work for due, there's not a whole lot that you need here. How do I find degrees of freedom? How do I actually find it, even though this one's real easy?
Column number minus 1 times row number minus 1.
Number of columns minus 1 times number of rows minus 1. So there's 2 columns. There's 3 rows. So our degrees of freedom is 2. When I am writing out this, which is my test statistic, for this problem, what's the first number that I write right there? 49. So 49 minus 46.08 squared divided by 46.08 squared. No, divided by 46.08. And then I can actually do this and then now write my last one. 30 minus 32.24 squared divided by 32.24. And I get a chi-square test statistic value of what?
3.219.
What kind of shape does a chi-square always have? Right skewed. Should not go backwards there. And we're always going to be shading to the right. So here is my 3.2199. And I get a p-value for this problem of what? Which is not less than. So here we failed to reject the null hypothesis. Since the p-value is greater than alpha, we do not have enough convincing evidence that alternative hypothesis. Questions with that one? Do I need to write that out? All right, for the second one, I'm probably just going to talk through answer pieces. Your expected counts end up being, starting at the top left, 240.2044, and then going to the right, 731.7956. Your second row, 719.3775, and 2,100 91.6225. And the last row, is that 1231 or 231? 1231.4181 and 3751.5819. You end up getting a degrees of freedom of 2 because it's also the same setup as the other problem. Your chi-square value is 8.9835, and you get a p-value of 0.0112, which means that we're going to do what to the null hypothesis? Reject. Questions, and do I need to go over that in more detail? Y'all okay with that? Okay.